Mr. Jacob Nash right here, and I'm going to start these calculus lectures. I might have mentioned that a few months ago that I was going to do this. This might not be always the way I do it, but this is just what I have to do for now. But this video is basically going to assume that you know all the prerequisites, which I have videos on those already. And if you need anything in depth that you don't understand, like maybe graph transformations, any specific thing that you may have learned in algebra, geometry, or pre-calculus, I have a lot of videos dating back to 2020 that you could possibly watch. So obviously, if there's anything that you don't understand, just make sure you do that, because gaps in understanding is probably going to be your biggest enemy in math. So let's get started by introducing something that's very important for calculus. So before, when we solved problems, it didn't really matter exactly how you did it. So you could just solve a problem and then you could just get an answer. Okay, x is 3, and then there you go. You just circle your answer and you get it right on the test. Well, it's not going to be like that anymore, because now that we're in this level of math, we have to really prove every single thing that we do. And it kind of seems a little bit annoying, I'm sure, but it's just part of it. We have to do that. We can't just say something's true just because it is. Like, that's not enough. You kind of have to say. But we're going to give you lots of different theorems in this course that you'll be able to use to explain your answers. But you have to make sure, just like there's grammar in English class, that you use the correct grammar in math. Once again, kind of annoying, but this is just the way that we have to do it. So first, we're just going to talk about limits. That's pretty much the first topic we're going to go through. So what is a limit? Do you remember what it is? Well, when we're talking about limits, we're kind of talking about, like, we might have something like, what is the limit when f of x approaches x from whatever side? We could have the left or right hand side, but we'll talk about that a little bit later. But there's a correct way to write this, and I'll show you what that is. So you got to write lim, lim. And we're just going to use, as x approaches a could be any x value that we're thinking of, and f of x, which, remember, f of x is really just our function. It's technically the y, but we're just going to write f of x for now, approaches L. So if this is new to you, I think I taught this in the pre-calculus videos, and that was 3 years ago, so kind of hard to remember what I did. But anyways, what is this statement saying? It's saying the limit of f of x as x approaches a equals L. So then you might just say, okay, well, is this really just saying f of a equals L? Well, that's not the same thing, because this is saying, what this statement is, if you remember, this is basically saying when x is a, y is L, because remember, f of something is basically y. So this statement right here is saying when x equals a, y equals L. So remember, a and L could be any numbers. Like, that's why I'm saying that. So pretend like it said f of 2 equals 3. If we see this statement, remember what that means? That's saying when x is 2, y is 3. But these two things are not the same. The limit is not the same as this, and we'll see pretty soon why. I should not use that to erase, sorry. My videos will be better soon. I just have to do it this way for now. So what does this mean? Well, let's draw a little graph to see what we're talking about here. And if you do know this already, it might be a good review. So the a, like I said, is our x value, and our L is our y. So we could just have any function. Let's just say it's something like this. So what would this function really be? Well, if you remember, this would be a whole. See, that's why I made it like that. That means technically, if you had, well, not technically, it's true. What is f of a? So it's saying, this is meaning, what is the y value when there is a? So here's a, y value. It's not L because of this whole. So we have to say does not exist. But if there's something really important in this video that you have to look at is you can't say equals. So like that's something that is a common mistake that I used to make. You can't say it equals does not exist because that's just not right. It's just a rule that you have to follow. So you have to make sure you don't do that. So just do that. F of A does not exist. But the limit does. Well, how? Well, the limit is just saying what value does it approach. So what value does it seem like it's going to, basically. That's the kind of simple way to say it. Well, it seems like it's going to L, right? Like that's, if you didn't know about this, you would just say, oh, it looks like it's going to L. It looks like it's going to L. So that's what the limit is. It's like, what does it look like it's going to? That's kind of the way to say it. So in this case, this is the statement that would be correct. We have to say that, but later on in this video, I'll explain how we prove that, because you couldn't simply, if you were asked, what is the limit of this function, whatever, you couldn't just give this as your answer, L. Like you would have to explain, but pretty soon we'll get to that. And pretty soon meaning now. So there's basically two sides of a limit. I might have already talked about this in the pre-calculus videos, but in case you don't know, there's a left-hand side limit as well as a right-hand side. Sorry if this is being kind of slow, it looks like. Looks like it froze, sorry about that. All right, I gotta hang on a second for this to unfreeze. It's pretty frustrating, sorry about that. Okay, that's better. Okay, so there are certain ways that we have to write the left-hand and right-hand side limit. And the way is this. The left-hand side of limit we would write as this. Because this little minus up here, that means it's coming from the left. And then right here, you might guess what it would be for the right. And there's something, so you do a plus for the right. There's something that might be confusing. So we can draw this little graph again that we had before. Not going to be exactly the same as it was, but. Okay, so if we're talking about from the left, we're talking about this right here. This little section from negative infinity up to here. From the right is from here, this part. So that can seem confusing because you're like, technically you're going negative in your values. Well, it's from the right, so this is the positive side and this is the negative side. So just to make that clear. So there is a theorem that we need to know that can help us prove what I said before. So the theorem is this. Remember what I wrote before? I said you can't just say the answer is L. You have to prove it, and here's how, by this theorem. This is true if and only if basically the left hand and right hand side limit are the same. And we'll look at some examples if that doesn't make sense. And L has to be a real number. So these statements have to be true. The left hand and right hand side limit must be the same for the overall limit. This is basically called the overall limit. Both of these have to be the same for that to exist. Also, L must be a real number, meaning couldn't be infinity. So if both of them go to infinity, that's also not correct. But we'll talk more about that later, okay? Not in this video. So we will look at an example. Not to scale, obviously. Sorry about that. How about something like that? Well, we can answer some questions here, but you have to prove everything that you do, okay? So let's say this. No, actually, we'll just do this for now. Sorry. Okay. All right. What is the limit of f of x as x approaches -1? Okay. So basically, remember that this is just saying, what does it look like it's going to? What does the y value seem like it will be? Okay. So we see. Well, there's two values right here. That's a problem. And I should have put right here that this is positive 2. So you might be like, hey, is it -2? Is it positive 2? And then you might be tempted to just say, okay, it's 2 because there's a hole there. Incorrect, because then that means that you're thinking of what is f of -1. F of -1, the answer for that is 2. See? Because the point does exist here, but not here. So where x is -1, y is 2, not -2, because that's a hole right there. But that doesn't mean that that's the answer here. These are not the same. They can be the same, but they're not always. So that's something else important to realize. This cannot exist when this does, and vice versa. So these both don't have to exist at the same time, or they could be different. So how do we figure it out? Well, we have to look at the left and right-hand side limits. So you might be like, okay, from the left goes to -2. From the right goes to positive 2. So that means it doesn't exist because they're not the same. That's what you might be tempted to do also. Is this correct? Yes, but would this get you a point on the test? Probably not. And actually, remember, you can't have the equal sign too. So kind of it was wrong. But you can't just say this. You can't just say does not exist. You have to prove it. So here's how. All we have to do is write this. Oops. Sorry about that. We can put this here. I'll write it a different way. I'm sorry. There's probably there's a simpler way to write it. So we can just simply put this. The limit of f of x as x approaches -1 from the left equals -2. The limit of f of x as x approaches -1 from the right equals positive 2. And you can just basically say, therefore, and then that. And typically you wouldn't want to do an arrow like that. You would just write that down here. But for time's sake, I'm just not going to. But you can say that. So the grader would be like, okay, they know that these two aren't the same. So this is why they're saying this. So that's what I'm saying that you have to do in this class. That's kind of, we're talking about limits, but this is also the introduction to this way that you have to do things, because you have to be able to prove every single thing that you do. You can't just say this. It's simple and easy to just be like this. That's probably what we did in pre-calculus. But you have to be able to prove it, and it's not that hard to prove it usually. You just have to write something extra. But make sure you have the correct notation because, like I said, right here you couldn't put an equal sign. That wouldn't be correct. You just have to have it like that. So that's going to be all for this video. Like I said, I'm sorry for the unprofessional nature of these videos, but I hopefully will get back to my iPad and then I can just use that instead of having to hold a phone like this, use YouTube's crappy live stream service. I mean, it's kind of crazy that it froze for like 30 seconds when I have high-speed Wi-Fi, but anyways, thank you for watching.